Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things Gen Chem related. On this video, we'll be introducing how the periodic table is laid out and also introducing the final quantum number, the magnetic spin, and understand how it incorporates into understanding where electrons are found in an atom. Let's get started. So chapter 8 is all about understanding different periodic properties that are associated with different atoms and understanding how they correlate to where an atom is found on the periodic table. Now, much of what we know about how the periodic table is laid out is based off of some studies that were done by Mendeleev. And what he found was that when he started ordering elements by atomic mass, he kept seeing patterns of properties that would show up repeatedly. And he then started grouping these things based off of these patterns that were occurring, along with being in that order of increasing atomic mass, and was able to identify that many of these similar properties existed with things that had very similar makeups. Now, while what he did helped us to see what was happening, it didn't help us to understand why these properties were showing up repeatedly. And so if we think about how the periodic table is laid out, we know that on our far left-hand side, that's where most of our metals are found. The far right side is where our nonmetals are found. And then there's that middle section of these semi-metals, or things that have intermittent properties between the two. And so when you put these things in groups, you see that many of these things that are found in the same group on a periodic table, and by group, I mean column, they have very similar properties. So why was this happening? Well, again, while his periodic law allowed us to predict the properties, it didn't really explain the why. The why is really based off of those quantum mechanics that we introduced back in chapter 7 and that we're going to finish off in these upcoming slides. It's those quantum mechanics that are going to help us to understand why such properties exist based on where an atom is found on the periodic table. So the final quantum number that we're going to be adding to our arsenal is the electron spin, or the magnetic spin quantum number. And so some experiments that were done by Stern and Gerlach showed that a beam of silver atoms is split into two by a magnetic field. And this experiment revealed that the electrons that were found there, they started spinning on their axis. And so within that atom, half of the electrons were spinning in one direction, or pointing in that north direction. And then the other half were spinning in the opposite directions. Let's see if I can do this in real time. Okay, yeah. And so what this can be attributed to is that attraction to that magnetic field. And so the final quantum number that we're going to be assigning is this electron spin quantum number. And so all electrons have this fundamental property, and all electrons have the same amount of spin. Now, the orientation of the electron spin, again, is considered to be quantized, meaning there's a specific amount of energy associated with it. And it can only go in one direction or the opposite. Either it's spinning up or it's spinning down. And we'll be assigning values based off of the direction. Now, by convention, when we're representing these electrons in like an orbital diagram, we show them as a half arrow, which is what you can see on the right-hand side. So this quantum number that we're going to be assigning, this final quantum number, this MS value, is going to be based off if the electron is going up or if it's going down. If we have it going in the upward position, it gets the value of positive 1/2. And if we have it going in the downward position, it gets the value of negative 1/2. Now, that value is the last quantum number that we assign to an electron found within an atom. So remember, you have 4 quantum numbers. You have your N quantum number, which tells you the energy level, how far away from the nucleus it's found. Your L quantum number, which tells us the shape of the atom, or the shape of the orbital. The ML value, which tells you the orientation, which specific orbital are we dealing with. And then now the MS value is telling us what orientation is that electron spinning. Is it spinning up or is it spinning down? And so when we're putting all this together, we'll be assigning all 4 quantum numbers to an electron found within an orbital diagram. So one other rule that we want to remember as we are putting all this together to help us understand how all these quantum numbers coincide with one another is Pauli exclusion principle. So what Pauli exclusion principle tells us is that no 2 electrons in an atom can have the same 4 quantum numbers. They can't have the same N, L, ML, and MS value. And so what that means is, for us, is that in an orbital, no orbital can have more than 2 electrons, because if we exceeded 2 electrons within an orbital, then we would have electrons that have the same 4 quantum numbers. And we'll go through a practice with that in a second. So because of this, this allows us to predict exactly how many electrons would be found in any subshell that we know exists. Remember, there's the S subshell, the P subshell, the D subshell, and the F subshell. Well, your S subshell, remember, there's only one type of S that exists, one type of orbital. And so if the maximum number of every orbital is 2 electrons, that means in that subshell, there's 2 electrons found. In the P subshell, remember, there are 3 different types of Ps that exist based off of those ML values. So the subshell can hold a maximum of 6 electrons. In the D subshell, there are 5 orbitals, so there's a maximum of 10 electrons. And the F subshell, there's a maximum of 14 electrons, given that there are 7 orbitals. And so I'll show you how you can look at your periodic table shortly and identify where these orbitals are located, and even a quick trick to figure out what's the maximum number of electrons that are there. So if we put all of that together, this is really just kind of the summary slide for assigning these quantum numbers. So again, your N quantum number is going to tell us the location, how far away from the nucleus you are, and it's really going to dictate the size and energy of an orbital. The L quantum number is going to dictate the shape of the orbital. If it's 0, that's for S orbitals, 1 is for P orbitals, 2 for D, 3 is for F, and that can be any value from 0 up to N-1. Our ML quantum number, which is going to tell us the orientation of the orbital, can be any value from -1 to +1. And then last but not least, our spin value, our MS value, can be +1/2 or -1/2, and that's telling us the direction of the spin. If you like that housing example that I gave to you guys before, your N is your street, your L is the type of house that you're in, your ML is what's your address, which exact house are you in, and then MS is saying, are you upstairs or downstairs in that house, those electrons that are found there. Okay. And so if we put all that together, we can actually go through and assign quantum numbers for every electron that's found within an atom. And so for helium, helium would have an electron configuration. We'll learn more about electron configurations in later chapters, but I do want to show you how to go about assigning these values. So when N is equal to, for your electron configuration for helium, you would have an electron configuration of 1s2, okay? And so orbital diagram, that would mean a 1s, and we know s's, there's only one type of s orbital exists, so we only show one line, and we would put those electrons in that up and down orientation. When we're assigning these quantum numbers, we have to look at, okay, well, what energy level is it in? And we find that from this value right here. We also determine what the L value is based off of the orbital shape. We can base the ML value based off of which house, which orientation, which line is that electron found in. And then the MS value is going to come from the direction of your electrons. And so if we look at the first electron here in this orbital diagram, this one, we would say that the N value, well, the N would be 1. Now our L value, well, we see it's an s orbital. Remember, those values for L coincide with a specific orbital. So if our orbital is saying it's an s, then our L value must be 0, okay? And remember, your ML value is based on -L up to +L. So if L is 0, that means ML is 0. And for that other electron, the direction of it, it would be +1/2 because it's spinning up. Move out your way. And then the second electron now, if we look at the second electron, well, that second electron is also in the first energy level. So now we're focusing on this one. Well, it's also in the s orbital, so that means L is equal to 0. I know the only possible ML value is 0. And now the spin, the direction of that one is going down, so it'd be -1/2. And so if we tie in what we know about Pauli exclusion principle, we could not throw a third electron in here because that third electron would now have the same 4 quantum numbers as the first electron. And so remember, Pauli exclusion principle says no 2 electrons can have the same 4 quantum numbers. So therefore, each orbital can only hold 2 electrons, okay? I do want to do just one more practice with how to assign these quantum numbers before we tie up this video. And so let's say we had something like a 3p orbital here, and we have some electrons that are filled in here, and how we would go about assigning the quantum numbers for that electron. Again, the same process. Our n value, remember, is going to come off of this first number, so that's going to be 3. Our L value, well, we know when n is equal to 3, our L value could be 0, 1, or 2. However, because we are in the p subshell, our L value must be 1. Okay. Once we've defined our L value, well, the ML values could be -1, 0, or +1. And so you really just assign those based off of which one you're in. And so we would select -1 as our ML value. And then the MS value, which is talking about the direction of that electron, would be -1/2 because it's going down. I hope this video helped you understand how the periodic table is laid out and how to assign all 4 quantum numbers for any atom or electron found within an atom. Make sure you guys like, comment, and subscribe, and let me know what other content you would like to see. We'll be back with more videos in Chapter 8 coming up soon. Have a great day. Talk to you guys later. Bye-bye.